At the start of every lesson, it's important that you plug your USB into your robot. You'll be working with your files on the USB at all times, never saving them to the Raspberry Pi itself. It is your responsibility to make sure that every member of your group gets those files towards the end of the lesson. When you first open up your Raspberry Pi, you'll have to open the Thonny Python IDE, and that's this one down here. And basically this is a programming tool for programming Python. It's quite a nice one. It takes a while to open the first time, and I like to do a few things before I start. The first thing I'm going to do is I'm going to maximize it to full screen. The second thing I'm going to do is I'm going to go to Tools, Options, and make sure that line numbers are on. Okay, you can see that now I've got a line number there. That's always helpful. And the final thing I'm going to do is I'm going to save it to my USB, even though it's an empty file. And the one I'm going to do today is the first one, the LED activity. So basically going to go save, and I'm going to make sure it's onto my USB. So if I go to the main folder here, I can find my USB in Media, in Pi, and I should be able to see the name of my USB. My USB is called Store and Go. So I'm going to put Store and Go there. You see I've already got one Python file on there. Just ignore these things here, and I'm going to call mine LED Basics, which is the name of the first activity. So let's now import the LED function from the GPIO library. So from GPIO0, we're going to import the LED. Now the LED function will import once we have that command done. We're also going to import from time the sleep function. And the sleep function is like the wait command. It's going to basically wait for a certain period of time while that goes. Now what we're going to do now is we're going to tell the program or the robot which LED is connected to which port. So let's just start by trying LED underscore FR for front right, and that's going to be equal to capital LED, open brackets, and I'm going to start, I think, with 19, I believe it is. And I'm going to put a comment in here. This is the front right LED. Okay, so the front right LED is the one I have chosen there. And now let's just see if we can turn it on. So I'm going to type in a command, while true, and everything that happens here, this is where we put the code to make the robot do stuff. That's pretty straightforward. Everything that gets indented underneath here is what the robot will do while something is true, which is going to be pretty much until we tell it to stop. So basically I'm going to type in LED underscore FR for LED front light. I'm going to turn it on, open and close brackets, like so. LED underscore FR dot on. I'm going to make it sleep for 1 second. And then I'm going to type in LED underscore FR dot off. I'm going to open and close brackets, and then it's going to sleep for another 1 second. And then, because I'm not going to write anything else, the code's going to come back up here and do the same thing over and over again until that's done. I need to hit save, and then I can hit the play button, and that should run the current script. And I've accidentally typed in the wrong number. I've typed in a number for a motor, and you can hear that going there. So I'm just going to hit stop when it's stopped. There we go. So basically I've interrupted that and stopped it while it's off. 19 is definitely the wrong number. So basically just going to pause it for a second and make sure I have the right numbers written down. My bad, I was actually looking at the motor pin numbers. I'm going to start with 18 as my front light number. Now if I hit save and hit play, I'm putting it and it's now testing, but it's actually the front left hand side light, and I want it to be the front right hand side light. So I'm going to pause it for a moment. I'm going to write down all of the lights and make sure I get them all written down. And then I'm going to basically program it for the front left with the right number. Okay, so now my front right LED, which is on pin number 25, is now flashing, and I've written down all of the other numbers so I have them, and that's nice and useful for me. So that's how we make the LED light flash. So I've now written in the definition for each of my LEDs right here. Your numbers will probably be different for your robot. So basically working through now, it's now time to create some functions so I can turn groups of LEDs on and off at the same time. So I'm just going to create a function to turn the front ones on and turn all of the LEDs off. And that could be helpful for me. So the first way I create a function is to DEF for define function. And I'm going to call it front on, and then I have that little colon there, and it should indent. And everything inside the indent belongs inside the function, so it's part of the function. So LED underscore FR dot on will turn both of the front ones on, and LED, underscore FL dot on, that will turn both of them on. And now I need to turn them off so I can take it back out to the outdent there, and DEF is all off, open and close brackets, semicolon, or sorry, whatever that is, colon, and I need to turn them all off, so LED underscore FR dot off, open and close brackets, LED underscore FL dot off, open and close brackets, LED underscore RR dot off, and LED underscore RL dot off, open and close brackets. I can now go in here and I can turn, instead of using this command, I can go front on, open and close brackets, and then I can type in all off, open and close brackets. So now if I save that, provided I haven't written any errors, they're now both turning on and off very nicely. The final thing we're going to do is we're going to fix a small problem, and it's a small problem when we're using LEDs, but it will become a very big problem when we're using motors. And the problem is when I stop my script, whatever the robot was doing, it keeps doing. So at the moment, both my front lights are stuck on. So I need to actually make a cleanup script in order to clean up my robot to make sure it doesn't create any problems for me. So the way we do that is we hop around this while true business and we actually type in the word try, and we press enter here, and that's going to bring that down to the next bracket, and we need to then indent all of this stuff as well. So basically I'm just going to press the tab button to indent. So the tab button to indent, and you can see that's now all indented. And if I press enter and then go back to the main part of the column here, I'm going to type in accept. And the thing I'm going to look for when I accept is called a keyboard interrupt. And you'll notice that when I press the stop button, it says keyboard interrupt. So it's going to try to do this, which it will do, until it receives a keyboard interrupt, in which case it'll do what's here. And this is where we clean up our robot. And we need to clean up our robot. And all we need to do at the moment is all off. So all lights should go off. And because I'm actually just using LEDs at the moment, all off is acceptable, but I should put in here all lights off and call that all lights off. and call that all lights off. And that's a better way of doing the code. So this is where we clean up our robot. I'm going to hit save now. Now if I press play, it'll run the current script. I haven't got any errors. It's flashing now. And no matter when I press stop, it turns the lights off, which is good. Not too bad with the lights staying on, but if the motors were on, it would just keep on driving and it might just crash or something. So it's a good idea to clean up your robot by basically having that accept keyboard interrupt section down there. In order to complete this activity, you'll need to sign off or have your teacher sign off on either satisfactory, commendable, or exceptional as to how you've completed it. To complete it to a satisfactory level, you need to show your teacher at least one LED that's flashing. In order to receive commendable, you just need to show your teacher the code as per the tutorial. In order to get exceptional, you need to create your own useful custom LED functions.